So in this third and final part, I'm going to be talking to you about how to name acids. Again, just like with the other parts, I'll start off by giving a rough definition of what an acid is. Okay, so an acid, in this case, is just going to be hydrogen bonded to an anion uh, dissolved in water. Now, there's another word for dissolved in water. We sometimes call this an aqueous solution, so just keep that in mind. Now, there are actually two sets of rules that we have here, instead of just one, for binary acids and for oxyacids. Now, there's a difference between these two, as if you haven't guessed. So binary acids, what a binary acid is it's an acid with hydrogen and one other element. Then oxyacids is, instead of just one other element, it normally has a polyatomic ion. And as it hints by the name oxy acid, these polyatomic ions are the ones with oxygen in. So because we're working with polyatomic ions, you're going to want to have your chart of polyatomic ions ready with you for this talk. Okay, so let's start with the rules for naming binary acids. Now, they're pretty simple. If you're naming a binary acid, you start with the prefix hydro and the suffix ic. And what you do is you put the element that's paired with hydrogen in between those two, right? And then you end with the word acid. Now for oxyacids, it doesn't have a prefix hydro. So that's a big indicator of if you are given a name, which of these two categories it falls into, whether or not it has the prefix hydro, so keep that in mind. Now, instead of having the prefix hydro, it has a different rule of thumb. And this rule of thumb is quite similar to the table I showed you in the ionic compounds video. So, hopefully you remember these names here: per-ate, ate, ite, and hypoite. And then as you move up here, the number of oxygens increases. So perchlorate is going to be the most oxygens, then hypochlorite is the least oxygens. That's how you'd name it for ionic compounds. Now how you'd name it for acids is you just say, okay, if it was an ionic compound, it'd be this. So because it's an acid, it's this. And then you do that for all of these. And then just like with the binary acids, it ends with the word acid. So those are the rules, and now we'll go through some examples to show you how to use those rules. So let's say we were given the compound H2S, and again it's aqueous, it's dissolved in water. Now what would we name this? Okay, so first off we want to determine if it's binary or an oxyacid. Well, it's hydrogen and one other thing. In this case, that one other thing is sulfur. So it would be a binary acid. Now, because the element paired with hydrogen is sulfur, we would end up with hydrosulfuric. Okay? So we have hydrosulfuric, all one word, and then end with the word acid, so acid. And that would be the name of H2S, hydrosulfuric acid. Now let's move on to another example. H3PO4, again, aqueous. Okay, so we have H3PO4. Now, right away I can tell it's not binary, because binary means 2, right? we have hydrogen, phosphorus, and oxygen. That's 3. So it's not binary. We're going to use the oxyacid rule. Because, again, oxyacids are the polyatomic ions, include the polyatomic ions with oxygens in them. So, like that right there. So let's identify what that is on this chart, that PO4. Now, if you take a look at your sheet of paper, or if you have it memorized, you should be able to see that this is the polyatomic ion phosphate. So that means as an acid, it becomes phosphoric. So we have phosphoric, and then you end with the word acid. And that's how you name that one. Now, again, just like the previous one on the ions, let's go through the opposite direction. If you were given the name and you want to know what the compound is. So, let's start with this one right here, hydrobromic. Hydrobromic acid. Okay, so what's the compound for that? Now, remember what I said earlier. It has the prefix hydro, so that right there is an indicator it's a binary acid right away. We know what type of acid it is. So all we need to do is think, okay, we have bromic right there. So that would mean we're working with bromine. So hydrobromic, let's balance the charges here. We know that the acid is H. So, and the acid, we normally say that the hydrogen has a +1 charge. Now we also have Br, and then minus. Based on its location on the periodic table, it's only 1 away from the noble gases, so that means it's going to be a -1 charge. Now, we can see if we put these two together, the +1 and the -1 instantly balance out. So this right here can just be combined to be HBr, hydrobromic acid. And then that would be our final answer. Now let's do it with one more example. Let's say we were given sulfurous. Acid. Okay. Now right away, we should realize this is an oxyacid, not a binary acid, because it doesn't have hydro. So, it's a binary acid, it's an oxyacid, meaning that this is going to be somewhere on this table. Right? And right there we see the us, O-U-S, which matches ours. So that means we're looking for, instead of sulfurous, we're looking for sulfite. So if you take a look at your polyatomic ions chart, you'll see that sulfite is SO3 2-. And then again, hydrogen, when it's an acid, is H+. So in order to balance out this -2 charge with a +2 charge, we're going to need 2 of these hydrogens. So that would give us H2SO3. And then that there would be our final answer. And that is the gist of naming acidic compounds.